My name is Cooper Hawkins. I'm going to study mechanical engineering and I'm a cyclist.
Hi, I'm Leo. I'm going into computer engineering and I'm a pedestrian.
I'm Quinn Gray. I'm going into electrical engineering and I am a pedestrian.
Hey, I'm Sanjay. I'm going into computer engineering and I'm a pedestrian.
With prospective 50,000 students at Purdue this fall, commuter safety must be a priority. Most classes are within walking and biking distance, so the roads of Purdue can be clogged and hard to navigate. This can lead to confusion along the roadways and to accidents, which can often be fatal. Our team, Goblin Barrel, aims to assist in the safety of Purdue's commuters, pedestrians, and cyclists with our project. We are specifically looking to improve the safety of Purdue's cycling community, as statistically, cycling accidents prove to be fatal more often than pedestrian accidents. Cyclists are moving much faster, making accidents much more frequent and dangerous. Cyclists are also much more prone to run red lights as they have no way to make the light change for them. This project will assist in cyclist safety and promote overall commuter safety by making Purdue's roadways safer and clearer.
Our weighted decision matrix determined the criteria of whether our prototype was economically viable, visually pleasing, easy to install, and whether or not it was environmentally friendly, as well as the constraints of whether or not it has the ability to be designed and iterated on a larger scale, as well as if it solves the problem that was given. Each of these criteria and constraints were each given a weighting determined by our group and research that we had done through surveys and to our fellow classmates that were able to determine whether or not certain aspects were more important than others. Using these weightings, we were able to determine that the bike detection prototype was a standalone best prototype that we had available.
Every 5 cyclists would run a red light. So we came up with this innovative design that detects bikes within a proximity of 1.5 meters. As soon as that proximity has been triggered, the ultrasonic sensor communicates with the pedestrian signal button, allowing the light to turn from red to green. This way, the bikers don't have to wait for a period longer than 30 seconds or get off their bike to go press the pedestrian signal. As soon as a bike leaves the proximity, the light changes from green to yellow to red, signaling the bikers to not cross the crosswalk.
When cyclists and cars interact at an intersection, accidents may occur. Our team aims to help with this by giving cyclists their own way of letting the intersection know that they are there. Our solution consists of a 3D printed housing that contains an MSB430 microcontroller, a generic breadboard, and an ultrasonic ranging sensor. The idea is that this would wire into the existing traffic signal much like a pedestrian button, and once a cyclist has been sitting outside of the sensor for long enough, it will send a signal to the traffic system letting it know that there is a cyclist waiting to cross. After a short period of time, this would change the light in their favor, allowing them to cross safely in an otherwise very busy intersection.
The TI kit includes an ultrasonic sensor and an LED that acts as a traffic signal. The LED stays red if no cyclist is detected. If a cyclist remains within the sensor's range for 5 seconds, the LED turns green. After the cyclist crosses the sensor, the LED turns back from green to yellow and then to red. If the cyclist does not remain in front of the sensor for over 5 seconds, the LED remains red.
We are Team 4, Goblin Barrel, and our solution will help improve cyclist safety on campus.